Episode 2 of the World of FPGA podcast. In today's episode, we will take a look back into the history of programmable logic. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. Today we will do a little time travel. I would like to give you a short overview over the development of the last round about 5 decades since the first programmable logic was developed. It began in 1969, where Motorola developed a mask programmable gate array with just 12 gates and 30 uncommitted input and output pins. And that's the start of the programmable logic we know today in, for example, in the kind of FPGAs. In 1970, the next company developed a mask programmable IC. It was Texas Instruments. They developed the IC TMS 2000, and this kind of programmable logic device has up to 17 inputs and 18 outputs with 8 JK flip-flops just for memory, just to store some bits. And Texas Instruments has coined the term programmable logic array for this device, or in short, PLA. A programmable logic array has a programmable AND gate array, which links to a programmable OR gate array, which can then be conditionally complemented to produce an output. 1 year later, in 1971, General Electric Company, on short GE, was developing a programmable logic device based on the new programmable read-only memory technology. The new technology also is in short PROM or PROM. And the GE device was the first erasable PLD ever developed. It's predating the Altera ePLD by over a decade. So this is a new technology. The first 2.1, just to make a short break here, the first 2.1 from Motorola and Texas Instruments were mask programmable. So in factory, they have to change the metal mask to reprogram this chip. So a mask change was needed to reprogram this kind of programmable logic component. And the interesting thing now is that we have a device that is erasable. So we can now program it and erase it and reprogram it while we are developing our kind of hardware. 2 years later, in 1973, National Semiconductors introduced a mask programmable PLA device with 14 inputs and 8 outputs, but with no memory registers in comparison to the Texas Instruments component. Then some years later, MMI introduced a breakthrough device in 1978. It is the programmable array logic, on short PAL or PAL. PAL devices have arrays of transistor cells arranged in a fixed or programmable end plane, used to implement sum of products binary logic equations for each of the outputs in terms of an inputs and their synchronous or asynchronous feedback from other outputs. And later on, around seven years later, in 1985, there was an improvement of the PAL device, and it was the generic array logic, or in short, GAL. This was invented by Lattice Semiconductor, and this device has the same logic properties as the PAL, but it can now be erased and reprogrammed. And this is much easier to use this in development stages where you're creating your new hardware and firmware. Well, PALs and GALs are available only in small sizes. It's an equivalent of a few hundred logic gates. If you want to implement bigger logic circuits, there were the complex PLDs, on short CPLDs, and these contains the equation of several PLAs linked by programmable interconnections. And this was all in one integrated circuit. CPLDs can replace thousands or hundreds of thousands of logic gates. And since today, you can buy these CPLD devices to create such a logic, such a hardware with programmable logic. In the late 1970s, to go a little bit back, a separate stream of development has happening. This type of device is based on gate array logic, gate array technology, and is called the field programmable gate array. On short, FPGA. Here we are. Now we have our FPGA. And they are using a grid of logic gates, and once stored, the data never changes, similar to that of an ordinary gate array. The term field programmable means the device is programmed by the customer, not the manufacturer. The main difference between FPGAs and CPLDs is that FPGAs are internally based on lookup tables, whereas CPLDs form the logic functions with C of gates, so for example, sum of products. And CPLDs are meant for more simpler designs, while you can use FPGAs for more complex designs. Or in general, CPLDs are a good choice for a wide wide combinational logic applications, whereas FPGAs are more suitable for large state machines such as microprocessors. I hope you have now a little insight into the history of programmable logic. Some more information you can find in the show notes at world-of-fpga.com/WFP002. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here, and next time, your David Kirchner.